Welcome to Math Magnet. Learn, grow, achieve. Today we will quickly understand real numbers. We're going to keep this super fast, totally focused, and specifically designed to get you exam ready in literally no time at all. So let's get right into it.
Okay, here is your ultimate one-page revision guide for Chapter 1. We're going to absolutely crush this topic for your Class 10 math exam. We'll be breaking down all the core concepts, step by step, so it actually makes perfect sense.
First things first, we need to establish a massive foundational rule. Real numbers, well, they make up absolutely every number you see on the number line. It's the whole shebang. And from there, they instantly split into two very distinct categories: rational and irrational numbers.
Now here's the absolutely critical difference you need for your exam. Rational numbers, they're either going to completely terminate or they'll repeat in a nice, clear pattern. But if you contrast that with irrational numbers, think of things like pi or the square root of 2. They never terminate, and they never, ever repeat.
So, how exactly do we handle prime factorization? The crucial rule to remember is this. To find the highest common factor, or HCF, you use the smallest power of each common prime. But for the LCM, you got to take the greatest power of every single prime involved. As you'll see with the example of the numbers 6 and 20, keeping those powers straight is absolutely key.
And that actually brings us to the golden formula. Guys, this is your ticket to quick, easy points on the test. It states that the HCF multiplied by the LCM perfectly equals the product of your two numbers. But, and this is a big warning here, this formula only works for two numbers. Literally, do not try to use it for three numbers or you're definitely going to lose points. Two numbers only.
Okay, let's shift gears for a second and talk about those heavy-hitting proof questions. We're looking at Theorem 1.2 now, which is pretty much the core logic for your exams. The rule is surprisingly simple but so powerful. If a prime number, let's just say 2, divides a squared number, like a squared, then it absolutely must divide the original number, a. You really want to keep that logic locked in.
Why? Because you're going to need it for this basically guaranteed exam question, proving that the square root of 2 is irrational. So step 1, we assume root 2 is a rational fraction, a over b. Step 2, we square both sides to get 2b squared equals a squared. What does this mean? It means 2 divides a squared, so it must divide a. Then step 3, we substitute a with 2c, which actually proves 2 also divides b squared. Boom, there is our contradiction. Since both a and b are divisible by 2, it means our initial assumption was completely wrong. Root 2 is definitely irrational.
Now, what about composite irrationals? Something like 5 minus the square root of 3. Well, there's actually an ultimate shortcut for this. You just rearrange the equation to isolate the root on one side. So root 3 equals 5 minus a over b. By doing this, you're clearly showing an irrational number sitting directly across an equal sign from a rational number. And honestly, that's a mathematical impossibility, which elegantly proves that the whole expression has to be irrational.
All right, let's wrap this up with a final rapid-fire recap. Number 1, every single composite number has a totally unique prime factorization. Number 2, remember that golden formula? It only applies to two numbers. And number 3, any operation between a rational and an irrational number is always going to be irrational. It's really that simple. Hope this quick revision helped you. Don't forget to like, share, and subscribe to Math Magnet for more easy math learning explainers.